Hi, in this lecture, we will learn about determining the derivative of a function using the first principle. And this is the formula of the first principle that you have to remember or memorize. Let's go straight to the examples. How to differentiate each of the following using the first principle. Example 1a. Look at this function. This is function of f equal to 3x plus 2. Now, to solve by using first principle, we have to remember this formula. So write down the formula, and then to replace the formula, we need to have the function of x plus h. And x plus h here simply means that this x has been changed to x plus h. So just replace that x with x plus h, and then just expand to simplify. After you are done finding this term of f of x plus h, replace it in the formula. Write down the formula including the lim word and also the h approaching to 0. Start by writing down the function of f, x plus h, and then subtract it with the function of fx. The function of fx is 3x plus 2. In front of 3x plus 2, there is the negative sign. So you have to expand this negative sign. That's why you get negative 3x minus 2. Be careful with that negative sign. Make sure you put a bracket before you expand. Next, you have to simplify this. 3x can be eliminated because 3x minus 3x will be 0. 2 minus 2 is also 0. Just write down 3h over h. After you have simplified, try to substitute in 0 into this function. What you get is 0 over 0. Remember, whenever you get 0 over 0, what you have to do? You have to factorize or multiply with conjugate. But can we factorize or multiply with conjugate for this question? Well, there's nothing to factorize and there's nothing to multiply with conjugate. Remember the important steps after you have factorized and also after you have multiplied with conjugates. After you have done these two, the most important thing is you have to cancel off that factor, which makes it 0. So for this question, you have 3h over h, and the one that makes it 0 is just h equal to 0. So just cancel this h. Once you have cancelled off h, what you have is limits of 3 as h approaching to 0. And 3 is a constant, so it will be equal to 3. So let me write down the steps for you to follow. The first step is to find your function of f in terms of x plus h. Second step is to substitute into your formula of this first principle. You have to remember there's a minus for the function fx. Expand your minus sign. Next, third step is to simplify what you have at the numerator. The fourth step will be to factorize or multiply with conjugate until h is cancelled. So this is your fourth step. Just follow these 4 steps to solve by using first principle. Try out example 1b. Now look at example 2. By using the first principle, find the first derivative of the following functions. Example 2a. The function f is 7x squared minus 3x. First step, remember, is to find your function f in terms of x plus h. So just replace your x with x plus h. Replacing all of the x with x plus h. The first term of x has power 2. So that means we have x plus h brackets is also power 2. But the other one is just power 1. So just write a bracket there and x plus h. Next, your second step is to substitute into the formula of the first principle. So the first few terms here would be the f of x plus h, subtract it with the function of fx. Make sure you put a bracket for the function fx because the minus sign is for all of the terms inside this bracket. Do you remember what's your third step? Your third step is to simplify the numerator. So to simplify this numerator, what you have to do is just to open your brackets. Expand your x plus h bracket squared. x plus h bracket squared simply means x plus h multiplied with x plus h. Expand this one by one, and what you get is x squared plus 2xh plus h squared. After that, just expand this negative 3. Open the bracket and you get negative 3x minus 3h. Also the same for the term behind. Open your bracket and multiply with that negative sign. And what you get is negative 7x squared plus 3x over h. Your third step is to simplify the numerator. So have you simplified the numerator? Well, you have just expanded and opening up your brackets, but you have not simplified it yet. Simplified means if there's anything that you can cancel off, please do cancel it off. But you have not tried to look at it yet. You can cancel off 7x squared with 7x squared. And then we have 3x eliminated. The 3 terms left cannot be eliminated, but we have h for all of them. So this means we can factorize that h. So this is our fourth step, which is to factorize to cancel off with the h at the denominator. Because if we substitute in 0 here, what you get is 0 over 0. That's why you have to factorize that h so that we can cancel off with the h at the denominator. After you have cancelled off that h, you can substitute in 0 into the function, replacing the h. Do not replace 0 at your x, because this is h approaching to 0, not x approaching to 0. What you have to substitute 0 is only the h. So you're left with 14x minus 3. Next example. This is ax squared plus bx plus c. First step is to find your function in the terms of x plus h, replacing all of the x with x plus h. Remember, your x in the front here has squared. So what you have to do is put a bracket for your x plus h and write a power for it. Placing your x with x plus h. Next, substitute into your first principle formula. Minus with the function of fx. Put it in a bracket and write the minus sign in front. Remember to write this bracket, because if not, then you will do a very big careless mistake right from the beginning. Next, simplify your numerator. Expand anything that you can expand. Please do take note that a, b, and c are just constants. They're just like numbers. Expand everything at your numerator and then subtract anything that you can. Ax squared can be eliminated. Next, you have the term of bx minus with bx and c minus with c. And what's left is just 2axh plus ah squared plus bh over h. Right now, if you substitute in 0 into the h, what you get is 0 over 0. That means you have to factorize the h until you can cancel off that h with the h at the denominator. After you have factorized, cancel off that h, then you can substitute in 0 into the h. Please do take note that here, the word lim still exists because we have not substituted in 0 into the h, and there is still h term here. But once we substitute in 0 into the h, that's where the lim word goes. So that will be your final answer. Now try out these 3 exercises. Thank you for watching.